Okay, so this is the long-awaited video instruction on 5.4, subtracting polynomials. Greetings, my students. This is Mr. D giving you the video instructions for subtracting polynomials. Here's the objective for this. I want you to be able to subtract polynomials symbolically. Pardon my handwriting here, and with tiles. So in this video, I guess what I'm going to do is actually I'm going to duplicate the notes that I gave you. Plus, in the end, I'm going to add how to do perimeter, or calculating the missing length of the rectangle when you're given a perimeter and a width. Yeah. So what I'm going to do is I'm going to duplicate what is actually happening, explaining your notes for you. So in your notes, if you already have it, and if you don't have it, it's actually in the Google Classroom already. I attached it there, as well as the assignment. And so I'm going to include this video in that assignment now. Okay, so here we go. This is the example that I gave you in the notes. Maybe I'll show it to you, and then I'll write it down after. So this is the polynomials I'm going to do. Okay. Negative 2a squared plus a minus 1 minus a squared minus 3a plus 2. Okay? So let's duplicate that. Let's put that in brackets. Negative 2a squared plus a minus 1 minus a squared minus 3a plus 2. Okay? So first I'm going to do it just strictly with polynomials. And this technique is easy because all you got to do is just add the opposite. Yes, that's the technique. Add the opposite. And I demonstrated this in class with when I was teaching you integers. Okay, so for example, over here, remember when you were doing integers, negative 3 minus negative 5, we simply just added the opposite, and we determine the result from there. Okay, so this is the exact same technique we're going to do with subtracting polynomials. So here we go. I'm going to write the first one stays exactly the same, but this becomes an addition, and this becomes the opposite. So where I have positive a squared here becomes a negative a squared. I have minus 3a here becomes a plus 3a, and I have plus 2 here becomes a minus 2. There. Now we don't really have to do any subtraction. We have an addition of polynomials, which we did in the last section. So now, if you recall from adding polynomials, what we do is just remove the brackets, like so. And when we remove the brackets from here, all we're doing is writing what's inside the bracket. So I'm just going to write down this, like this. Okay, and now let's try to finish this off by combining like terms. Remember this, we got to make our 2a's, or negative 2a squared, and beside, pair up with this minus a squared. So I'm going to pair those up. And again, just as a reminder, when you're shuffling these, you take the sign in front of it with him. Okay? Now I'm going to do my a's, and this plus 3a is going to go beside him. And finally, I'm just going to move this minus 1 back here with the negative 2, like so. And now we can actually just do the math with the coefficients. Negative 2 here and a negative 1 here. Both negatives, so we have negative 3a squared. 1 positive a here, a positive 3a there, and so we end up with positive 4a. And then finally over here, okay, this is negative 2 minus 1, that ends up as negative 3. And so there is our answer. Okay. That's subtracting polynomials symbolically. Okay. So now I'm going to show you how to do this using tiles. Now, as you know, there are two ways to do the tiles. In your notes, I actually showed you two ways. Method number one is called the remove or take away. So now we're going to be using algebra tiles. Okay, and this is method number one. It's called take away, remove. Or remove technique. Again, if you were in my class, you would have seen that if you don't have any tiles that you can actually take away from the first set, then you'll have to add 0 pairs. Okay, so let's try this. Okay, this is the original question here. Okay, negative. Actually, you know what? I think just to make sure that I actually have room here, I'm going to do this on another page. Okay, so here we go. Actually, I'll do it here. Save paper. Or we do this again. This is method number one. Again, this is the remove or take away. Take away or remove technique. Oops. Yeah, take away or remove technique. Here we go. Again, this is the original question was negative 2a squared plus a minus 1. And we're going to subtract a squared minus 3a plus 2. So in other words, the way you read this now is when you draw these set of tiles, this second part here, this minus a squared minus 3, this is actually instructions. It means from this set, take away these guys. Okay? So I'll show you how to do that now. So first thing I'm going to do is I'm going to draw the tiles for this. Okay? The tiles for this is two negative x squared tiles. There we are. Shade them in because they are negative. I have one positive a and I have a negative 1. Okay? And so this instruction, this part now becomes an instruction. It reads, you can read it this way. It says, take away an a squared tile. Take away 3 negative a tiles. And take away 2 positive tiles. Well, if this is my original set of tiles, I already have a problem. Because if it wants me to take away an a squared from here, I can't. I don't have any. So, what you got to do is add a 0 pair. And as you know, if you add 0 to anything, it doesn't change its value. So now here, I added a 0 pair of a squareds, but at least now I have an a squared I can take away. Oh, excuse me. So let's deal with the squared tiles first. So now that you have this, you can actually take that away. And I'm going to draw right away what I have left over of my square tiles. So after taking away that positive square tile, I'm now left with 3 negative a squared tiles. Okay, and I think this is the easiest way to do this, is just keep track of them. Just do it one tile at a time. Next, it wants me to take away 3 negative a tiles. I hope you see the problem here is I don't have any negative a tiles. I only have one positive a tile here. So guess what? I'm going to have to add those as 0 pairs. Here they are. These are 0 pairs. But at least now I can take away these 3. Okay, I'm just going to remove that. And I'm going to draw what I have left over. I have 1, 2, 3, 4. A tiles. Positive A tiles now. Okay? Next, it wants me to remove, from this set, it wants me to remove 2 positive little tiles. Again, a problem. I don't have any positive little tiles. So, guess what? I'm going to have to add those as 0 pairs as well. Here they are. Now we can take away these 2 positive little tiles. And what am I left with here? 1, 2, 3, negative tiles. Negative little 1 tiles. Okay? And then we've already done the polynomials in the beginning here. And we should have an answer over here. Does this answer match our tile? I hope so. Otherwise, I would have to start this video all over again if I made a mistake. So yes, we do have a negative 3a squared here, and we do have 4a over here, and a minus 3 over here. So here's our answer. Tiles and the polynomials, okay? They do match. Now, I'm going to show you method number 2, if in case you're not a fan of this method number 1. In your assignment, you actually have to do this method, and they show you diagrams of what they're taking away. This is question number 4, A and B in your assignment. But if you don't like method number 1, may I show you method number 2, which I actually like a little better. Here's method number 2. And guess what? This method is actually just like what we do in the polynomials, which is add the opposite. I don't understand why they try to change it back to this, maybe change it to this, when we already know how to do this one. Okay? And you'll see what I mean as I try to explain this. Okay. So again, if you were in my class, you might have seen this already. And it goes a little something like this. Again, I'm going to write the original polynomial question. Okay, minus a squared minus 3a plus 2. Okay. Oops, bracket. Okay, so now I'm going to draw the tiles for all of these guys, actually. I'm going to draw a tile for this set of polynomials. Like this. And I'm going to put a minus here. And I'm going to draw a set of tiles for this. A positive a squared, a negative 3a, and then a plus 2. So there we go. Here's our set of tiles for this question. Well, you know what? If we know how to add the opposite, why don't we just do that with the tiles? I'm going to turn this into an addition, and I'm going to turn this set into its opposite. Like so. And the reason why I like this better is because, well, isn't this what we were doing when we were adding polynomials anyway? So I just find it an easier, more convenient way of actually subtracting polynomials. So now, yeah, my instruction to you, you don't have to redraw this if you don't want, but might as well here. So I'm going to redraw this again. Again, you don't have to if you don't want. If you could see the 0 pairs from here across here, then you can just cancel the 0 pairs. But so now that you're at this stage, add the opposite. I'm going to put a note here, add the opposite. Okay. Now that you have this, you can now, if you can, if there's any 0 pairs between these two sets, then you can go ahead and cancel 0 pairs. But otherwise, I don't see any 0 pairs with these guys, so I'm just going to draw them the way they are. Okay. I don't see any 0 pairs with the A tile, so I'm just going to draw them the way they are. 4 of them. And I don't see any 0 pairs with the little ones. 3 little negatives, so I'm just going to draw them the way they are. And here they are. If there was 0 pairs, then just cancel them out and then just draw what's left over. But in this case, there was no 0 pair, oh pardon me, there was no 0 pairs to cancel each other out, so our answer is negative 3a squared plus 4a minus 3. And, you know, I don't mind you doing it this way. I think if this is easier for you, and I think it is, my opinion, then let's just use this technique, okay? Okay, so now, I think what I'm going to do is I'm going to give you an example of subtracting trinomials, let's say, with 2 variables, which is also in your notes, okay? And then I'm going to do one on perimeter. Okay, so here's continuation. So for example, if you have this set of polynomials, 5x squared minus 3x, and this is an example, again, in your notes, so I'm just repeating what you have and explaining it so that you have an explanation as you read it. Okay, so here it is. Well, again, the technique really is just to add the opposite, okay? I'm going to write this first set the way it is. Okay, so that reads 5x squared minus 3y plus 2y squared. This is going to turn into an addition. These guys are going to turn into their opposites. Okay, without a sign in front of this 8x squared, it is actually a positive. So if you want to turn that to its opposite, then it becomes negative 8x squared. This minus 7xy becomes plus 7xy, and this minus 4y squared becomes a plus 4y squared. Adding the opposite. Okay, now we remove brackets. 5x squared minus 3xy plus 2y squared. And now I'm going to write down, removing all these brackets, I'm just going to write down what's inside this bracket. Okay, so minus 8x squared plus 7xy plus 4y squared. Okay. Okay, here we go. So now I'm going to combine these like terms. This minus 8x squared is going to go beside this 5x squared. I'm going to write down my minus 3xy. I'm going to look for the other xy, which is here. I'm going to put that beside him, 7xy here. And then finally my y squareds, plus 4y squared. And I would just do the math with these numbers. Okay. And this 5 minus 8 here is going to be negative 3x squared. Wow, somebody please turn off that alarm. I have my windows here for a breeze, but that's not what I would want. Negative 3 plus 7, that's a positive 4xy. And then 2 plus 4 here is 6y squared. Okay? Add the opposite, combine like terms, and simplify. Okay? Now, I'm going to give you what was missing in your notes, okay? Which is finding, I'm going to handwrite here, finding the missing length when given perimeter and width. Okay, and it could be done exactly the same way if you're given the length and you're looking for the width. Okay, so I think this is the example that I gave you guys in class. If you're given a rectangle like this, let's say, you know, this is the nature of a rectangle. You have 2 equal opposite sides. And I gave you this as x plus 2, therefore this will be x plus 2. And then I gave you the perimeter for this is 6x plus 6. Okay, so just as a reminder, you know, a perimeter is actually adding up all these sides, yes? This plus this plus this plus. Don't get it confused with area. This is perimeter, okay? So right now this is this side plus that side plus this side plus that side. Well, what are we going to do here? Well, I think what makes sense is if we added these two sides and subtracted it from this perimeter, that is actually going to give us the total for these two. And if they're equal, then we have to divide them by 2. Okay? And you know, I'm going to give you a simpler example in this with actual numbers after. But let's see if you could follow this. Okay? So what I'm going to do is I'm going to add up these two sides. X plus 2. It's x plus 2. I'm going to add these up. When you add this up, you're going to get 2x plus 4. Okay? So now I'm going to take this, because this is the total of the widths, I'm going to subtract it from this perimeter. Okay? 6x plus 6 minus, you know, and this, yeah, this is why this is subtracting polynomials, right? So you can subtract this from the total perimeter. Okay, add the opposite. Okay, so move brackets. Combine like terms. And then we do the calculation. So this is going to become 4x plus 2. Okay, so this is the total of the length of these two sides. Then you would actually have to take this and divide this by 2. Okay, and here's how. Okay, 4x divided by 2 will look like this. 4x divided by 2 plus 2 divided by 2. And guess what? The length of this missing side is actually equal to, well, 4 divided by 2 here is 2, so this is 2x, and 2 divided by 2 here is 1. Okay? So why does this work? Well, if you watch this next example, let me show you another one which actually has, I'm going to give you actual width here. Okay, so let's say this is equal to 4. Therefore, this is going to be equal to 4. If our total perimeter for this is 20. Okay, and some of you did figure this out in class. Good for you, okay? But in case you didn't, well, here's a video to help you, okay? To figure out what this length is, I would actually have to add up these two widths and subtract it from the perimeter. Yes? So that's what I'm going to do. 4 plus 4. That's equal to 8. That's the total of these two widths. Okay, so we have 2 more we're trying to figure out here. So what I'm going to do is I'm going to take the perimeter, subtract 8 from it, and I'm going to get 12. This is the total of the lengths. Okay, so what have I got to do with this? I got to divide this by 2, which is 6. So the length for this rectangle is actually 6. Okay, I think that'll be the end of it. I hope you do use this video, and I hope this video does help. If not, we do have Google Meets, and you can bring in your questions then. Oh, I think I'm going to do another little short video just demonstrating how to do question number 4 in your assignment. So stand by for that, okay? Bye-bye for now.